Let's review the elimination method for solving a system of linear equations. Remember that a system is two or more equations, and in this case we're focusing on two linear equations. There are two variables. The elimination method takes advantage of the fact that sometimes when we line the terms up in standard form, we notice that we have opposites lined up above each other. And so what we decide to do is to combine these equations by adding straight down, eliminating the terms that are opposites, and we end up with an equation with one variable, and we can solve that. So that's our goal. We're trying to notice that they're opposites. Here we have a positive 5 and a negative 5y, as I circled them in green. And when we add these equations straight down, those terms will eliminate. We'll be able to solve for x, and then when we're done, we can substitute that value back into one of these equations. So let's give that a shot. Okay, so let's solve this system. You don't know this, but this is the third time I've done this problem. The first two times, I left off a negative sign, and I even knew that I wasn't supposed to do it. Anyway, we're using elimination. We're going to add straight down because we've already identified that we have opposites. 2x plus 3x is 5x. When we add those straight down, we get 5x. We've already mentioned that these are opposites. They're going to cancel out. And then negative 24 plus 14 is negative 10. Now here's the place where I twice made a mistake. And the second time, I even knew I wasn't supposed to make it, and I just rattled it off. We need to divide both sides by 5. I did that part right. But make sure when you divide, you get negative 2 for the solution, right? Negative 10 divided by 5 is negative 2. So that's the x-coordinate. And you know in elimination, after you find one of the variables, in this case the x-coordinate, you have to pick out the easiest equation, or the one that you want to substitute x in for. It's a toss-up here. I'm going to pick the top equation. It's got the plus 5y in the middle. That just looks a little easier to me. So instead of writing 2x, I'm going to write 2 times negative 2, right? We're going to plug that negative 2 in. We substitute it for x. 2 times x, which is negative 2, plus 5y equals negative 24. And the last thing I'll fit on this screen is I'm going to actually multiply 2 times negative 2, and I'm going to get negative 4 plus 5y equals negative 24. I'll finish that equation off on the next slide. We'll have our y value, and then we'll know our ordered pair. So here's that equation. Negative 4 plus 5y equals negative 24. We just need a couple inverse operations here. We're going to add 4 to both sides. That way this will cross out. I get 5y equals negative 20. And then, yeah, again, we divide by 5. And this time we get y equals negative 4. That's supposed to be y equals negative 4. Let's try that again. Okay, so we now have our solution, our ordered pair. The x-coordinate was negative 2. The y-coordinate is negative 4. That is a solution to this system. That point makes both equations true, and if you were to graph these, it's the place where the lines cross. Okay? We used elimination to solve this. We started by adding straight down, and the rest of it took care of itself. Good luck.